students, welcome back to our class. In the last class, we were discussing about multiplication of integers. We studied multiplication of one positive integer and one negative integer, multiplication of two negative integers, and multiplication of three or more than three negative integers. In this class, we are going to study properties of multiplication of integers. We are going to study properties of multiplication of integers. First property is closure under multiplication. Let us check integers are closed under multiplication or is applicable for closure property for integers. I am going to write some examples. Minus 5, it is an integer, into minus 3. I am going to multiply minus 5 and minus 3. What is the answer? 190. Here also 90. Minus into minus, multiplication of two negative integers is a positive one. So 5 into 3, 15. Minus into minus, plus. So minus 5 is an integer. Minus 3 is an integer. There is into minus 5 into minus 3 plus 15. The result is also an integer. Result is an integer. Result is an integer. Another one. Minus 10 into 7. I am going to multiply one negative integer and one positive integer. Minus 10 into 7. What is the answer? 1 negative into 1 positive. Answer is negative. 10 into 7, 70. So, minus 10 is an integer, 7 is an integer, their product minus 10 into 7, that is minus 70, which is also an integer. Another one, minus 12 into 3. What is the answer? 1 minus 1 plus multiplication. Minus 12 into 3. Minus 12 into 3 means 12 into 3, 36. 1 minus into 1 plus, answer is minus. So, minus 36, which is also an integer. So, here, minus 5 is an integer, minus 3 is an integer, plus 15. Their product plus 15 is an integer. Here, minus 10 is an integer, 7 is an integer, their product minus 70 is also an integer. Here, minus 12 is an integer, plus 3 is an integer, their product minus 36 is also an integer. From these examples, we can conclude that the product of two integers gives another integer. The product of two integers gives an integer. The result is an integer. So we can say that integers are closed under multiplication. Integers are closed or it has closure property. So integers are closed under multiplication. In general, for two integers a and b, let us write same as in addition. Now we are going to write the general case. If a and b are two integers, then their product a into b. A and b are two integers. Their product a into b is also an integer. This property is known as closure property. So integers are closed under multiplication. For a and b two integers, a into b or ab is an integer. So integers are closed under multiplication or it has closure property. Next property is commutativity of multiplication. I am going to write some examples. Look here, 5 into minus 3. 5 into minus 3. What is the answer? 5 into minus 3. Answer is minus 15. Okay. 5 into minus 3. 1 positive into 1 negative. Answer is minus 15. I am going to change the order. Which means I am going to find minus 3 into 5. Minus 3 into 5. What is the answer? Minus 3 into 5. 5 into minus 3, minus 15, 1 positive into 1 negative, multiply them as whole numbers and put the negative sign. So 5 into 3, 15, put the negative sign, minus 15. Here, minus 3 into 5, 1 negative into 1 positive, answer is minus 3 into 5 is equal to, which is also minus 15. So 5 into minus 3, we got minus 15, minus 3 into 5, we also got minus 15, which means 5 into minus 3 which is equal to minus 3 into 5. 5 into minus 3 is equal to minus 3 into 5. Another one, 11 into minus 1. 11 into minus 1. Can you say what is the answer? 11 into minus 4, 1 positive, 1 negative. Answer is negative. 11 into 4, 44. So answer is minus 44. So 11 into minus 4 is equal to minus 44. Now I am going to change the order, which means minus 4 first, then 11. So minus 4 into 11. What is the answer? 1 negative into 1 positive. Answer is negative. 4 into 11. 4 into 11. What is the answer? 44. So 11 into minus 4, minus 44. Minus 4 into 11, minus 44. So we can write 11 into minus 4 is equal to minus 4 into 11. Next one, minus 2 into 10. What is the answer? Minus 2 into 10, 1 negative, 1 positive. Answer is negative. 2 into 10, 20. So answer is minus 20. Here, now I am going to change 10 into, going to find 10 into minus 2. 10 into minus 2. 1 positive into 1 negative. Answer is negative. 10 into 2, 20. So minus 20. So here minus 20. Here also minus 20, which means minus 2 into 10 is equal to 10 into minus 2. So here 5 into minus 3 is equal to minus 3 into 5. 11 into minus 4 is equal to minus 4 into 11. Minus 2 into 10 is equal to 10 into minus 2. So when we change the order, the result is same. In the case of multiplication of integers, when we change the order, the result will be same. So we can multiply integers in any order. So we can say that integers can multiply in any order. Other words, we can say that multiplication of integers are commutative. So integers have a commutativity property under multiplication. So integers are commutative under multiplication. In general, we can say that, or we can say that for any two integers a and b, for any two integers a and b, what we can say, we can multiply in any order, which means for any integers a and b, a into b, which is equal to b into a. This property is known as commutativity of multiplication of integers. For any two integers a and b, a into b is equal to b into a. So a into b is equal to b into a. Next one, multiplication by 0. Here I am going to write some example. Minus 5 into 0. What is the answer? Minus 5 into 0. It's very simple. Answer is 0. 0 into minus 11. What is the answer? 0 into minus 11 is also 0. Then minus 100 into 0. What is the answer? Minus 100 into 0 is also 0. So when we multiply by 0, what is the answer? We will get 0. So when we multiply an integer with 0, we will get the answer 0. So in general, for any integer a, in general we can say that for any integer a into 0, which is equal to 0 into a, which is equal to, answer is 0. So when we multiply 0 with an integer, the answer is 0. So for any integer a into 0, which is equal to 0 into a, which is equal to 0. Next one is, fourth one, multiplicative identity. Multiplicative identity. Fourth one is multiplicative identity. Multiplicative identity. Can you say which is the additive identity of integers? We studied that 0 is the additive identity. Now we are going to study multiplicative identity. Okay. Can you say the answer of minus 5 into 1? What is the answer? Minus 5 into 1. Answer is minus 5. 100 into 1. 100 into 1. What is the answer? 100. minus 10 into 1. What is the answer? Minus 10. 1 into minus 3. What is the answer? 1 into minus 3. Positive into 190. Answer is 90. Answer is minus 3. So, when we multiply an integer with the 1, we will get the same integer. When we multiply an integer with the 1, we will get the same integer. Minus 5 into 1, minus 5. 100 into 1, 100. Minus 10 into 1, minus 10. 1 into minus 3, minus 3. So, when we multiply an integer with the 1, we will get the same integer. So, we can say that 1 is the multiplicative identity. 1 is the multiplicative identity of integers. Where 0 is the additive identity. Here 1 is the multiplicative identity. In general, we can say that for any integer a, in all cases we are saying the general case, here also for any integer a, 1 is the multiplicative identity. 1 is the multiplicative identity for any integer a into 1 which is equal to 1 into a. A into 1 is equal to 1 into a. For any integer a into 1 is equal to 1 into a which is equal to a. So, when we multiply an integer with the 1, we will get the same integer, where 1 is called the multiplicative identity. Next property is associativity for multiplication. So, property number 5, associativity for multiplication. Here I am going to multiply minus 3, 2 and 5. I am going to multiply minus 3, 2 and 5. First I am going to multiply minus 3 into 2, then 5. What is the answer? Minus 3 into minus 2. 1 minus into 1 positive. Answer? Minus 3 into 2, minus 6 into 5. What is the answer? Minus 30. Now I am going to multiply minus 3 there, 2 into 5. First I am going to multiply 2 and 5, then with the minus 3, which is equal to minus 3 into, first I multiply 2 into 5, 2 into 5, 10, which is equal to minus 3 into 10, minus 30. In both cases, answer is same. So, here first we multiply minus 3 and 2, then with the minus 5. Here minus 3 there, first multiply 2 and 5, then with the minus 3. But in both cases, answer is minus 3. Another example, 1 minus 4 minus 5. First I am going to multiply 1 into minus 4, which is equal to 1 into minus 4, minus 4, minus 4 into minus 5, answer is 20. In second case, I am going to multiply 1 minus 4, minus 5. First multiply minus 4 and minus 5. So, here first multiply 1 and minus 4. Here minus 4 and minus 4. So, 1 into, what is minus 4 into minus 5? 2 negative. Minus 4 into minus 5 plus 20. So, 1 into 20. Answer is 1 into 20, 20. In both cases, answer is 20. Here, both cases, answer is 30. Minus 30. So, here, in both cases, answer is minus 30. Here, answer is 20. So, when we multiply in integers, we can place the brackets or we can multiply in any order. First, we can multiply minus 3 into 2, then 5. Here, 2 into 5, then minus 3. Here, 1 into minus 4. First, here, minus 4 into minus 5. So, we can put the brackets anywhere. Then the answer will not change. So, this property is known as associativity for multiplication. So, we can place the brackets in any order. So, this property is known as associativity for multiplication. In general, we can say that for 3 integers a, b and c. So, in general, we can say that for any 3 integers a, b and c, a into b into c. So, I put bracket here, a into b into c, which is equal to here a into b. Put bracket here, then c. So, we studied closure property, commutative property, multiplication by 0, multiplication by 1 and associativity of multiplication of integers. Thank you.